Okay, let's dive right into this explainer and completely demystify the process of building a cost-effective, manual geothermal heating and cooling system for a multi-story ground-plus-2 house. I mean, if you've ever stared at your energy bills, and honestly, who hasn't, and just wish there was a more natural, DIY-friendly way to maintain a comfortable temperature across a large home, well, you are in the exact right place. We're going to unpack a brilliant master plan that literally turns the Earth itself into your primary climate control engine.
Here's our blueprint for today. We'll start with the geothermal master plan, then move right into Phase 1, the earth tubes, followed by Phase 2, interior infrastructure, and finally Phase 3, manual operation.
Section 1, the geothermal master plan. Before we grab the shovels and start tearing up the yard, let's establish exactly what this infrastructure is designed to achieve.
So the absolutely crucial takeaway here is that this system basically plugs your house directly into the Earth's crust. It's wild. It simply uses the constant natural temperature of the ground combined with cool night air to manage your home's climate. By routing air through a network of underground pipes, we can actually pre-cool our home in the blistering summer and preheat it in the freezing winter. It's a highly efficient, manually operated network that works with nature rather than constantly fighting against it.
Phase 1, the earth tubes. Let's move outside and see how this builds from the ground up, starting with the heavy lifting out in the yard. This underground installation follows 4 incredibly precise, sequential steps to ensure those earth tubes function perfectly. And listen, skipping or rushing through any of these will drastically reduce the thermal efficiency of your whole system. We're talking about excavation, laying the pipe, ensuring the perfect grade, and then meticulously backfilling the trench. Let's break down exactly what each of these steps requires.
First up, obviously, is excavation. You're going to need to dig trenches about 5 to 6 feet deep in that easy-to-dig clay soil. Now, you might be wondering why 5 to 6 feet. Well, we need to get these pipes well below the surface weather layer. Down there, the temperature of the earth stays relatively constant all year round. Oh, and a quick tip, if you're running parallel trenches, make sure you space them at least 10 to 12 feet apart. If you don't, they'll just end up competing for the exact same thermal energy, and we definitely don't want that.
Now, what's really fascinating here is the sheer scale of the pipe laying. Get this. You'll run 3 to 4 parallel lines of 6-inch, rigid, smooth-walled HDPE or PVC pipe for a solid 100 to 150 feet before they even merge. Inside the trench itself, you'll want to keep those individual lines about 3 feet apart. And then, after that massive 100 to 150-foot run, those 6-inch pipes merge together into a single, huge, 10-inch main trunk line that heads straight into your house. This gives the air plenty of time and surface area to cool down or warm up as it makes its way towards your living space.
Okay, gravity is your absolute best friend here. Maintaining a 1% to 2% grade on these pipes ensures that any summer moisture collects harmlessly in a drain or a dry well. Think about it. When that warm, humid summer air hits those cool underground pipes, condensation is literally inevitable. If your pipes are perfectly flat, the water is just going to pool up, inviting mold and totally restricting your airflow. So that slight, deliberate slope, it completely prevents a total disaster.
This next part brilliantly illustrates the precision required during backfilling. You can't just blindly dump the dirt back into the trench. You actually have to hand-pack the first 6 to 12 inches around the pipe with fine, rock-free clay or even a wet clay slurry. Why? Because air is a thermal insulator. Any tiny air gaps will completely ruin your system's efficiency. By eliminating those gaps and ensuring 100% direct contact, you get maximum thermal transfer between the soil and the pipe. Once you've got that perfect contact, then you can carefully pack the remaining dirt in layers or lifts to handle natural clay shrinkage over time.
Phase 2, interior infrastructure. With those massive underground earth tubes successfully buried, let's transition inside the house to set up the central nervous system.
Here is a direct look at the source document detailing the precise fan setup and interior ducting we need for this phase. To pull this whole thing off, we basically take that big 10-inch main trunk line we just brought in from the yard, and we distribute that beautifully tempered air all throughout the 3-story house.
Let's actually trace the path of a single breath of air as it moves through this setup. First, it comes out of that 10-inch pipe into a ground floor utility closet and hits a galvanized metal Y junction box. One leg of that Y is your earth tube. The other leg goes straight to an outside wall so you can pull in fresh night air. On both sides, you're going to install a manual locking lever damper and a replaceable HVAC filter slot. to keep out bugs and dust. Right after that junction, you mount a really powerful 10-inch or 12-inch high-static inline duct fan. It needs some serious muscle to push air through hundreds of feet of underground pipe. And you just wire that up to a simple wall switch with a manual speed dial.
Now think of this air chase almost like a central closet column running vertically straight up through the house. It's basically a central spine that lets you cut adjustable supply registers onto the ground, first and second floors. But delivering the fresh air is really only half the battle, right? You also have to get rid of the stale, old air. To handle that, you install gravity shutter exhaust fans high up on an exterior wall on each floor. The brilliant thing about these is they automatically flap shut when you turn them off, so you don't get any annoying drafts. You position these exactly opposite from where your central air supply comes in, wire them to simple on-off switches, and boom, they pull that fresh, conditioned air completely across your living space.
Phase 3, manual operation. The infrastructure is built, so now we get to learn how to actually pilot this ingenious system across the different seasons.
Now remember, this isn't some smart thermostat you just set and forget. The master plan provides a strict operational guide for summer days, summer nights, and winter. It relies completely on you finding a daily rhythm with your dampers and fans. Your primary controls are essentially a DJ booth for your home's climate. You've got your earth tube lever, your outside air lever, your main intake fan, and those upstairs exhaust fans.
A totally foundational concept for making this work is something called the night air flush. This basically takes full advantage of those naturally dropping evening temperatures. See, rather than dragging air through your earth tubes 24/7, we completely switch up our strategy when the sun goes down. It's all about maximizing efficiency and preserving that massive underground thermal battery we just built.
Check out this table. It perfectly highlights that daily pivot I mentioned. So, on a scorching hot summer day, you open the earth tube lever, close the direct outside air lever, fire up the main intake fan downstairs, and turn on those upper floor exhaust fans to yank all that rising hot air right out of the house. But when summer nighttime hits, the script entirely flips. You close off the earth tubes, crack open a top floor window or a ceiling hatch, open the direct outside air lever, and use the main intake to just flood the house with crisp, cool night air directly from outside.
Now you might be wondering, why bother closing the earth tube lever at night at all? Well, it is an absolutely critical step. It actively allows the soil surrounding your underground pipes to rest and recharge for the very next day. If you just constantly forced hot summer air through those tubes without ever taking a break, the clay soil around the pipes would eventually heat up and you'd lose your cooling effect entirely. By switching over to direct outside air at night, the earth gets a chance to cool back down so your system is ready to perform at absolute peak efficiency the next morning.
Okay, so what about the dead of winter? Well, the system actually acts as a brilliant preheater. Instead of leaving it running constantly, you do what's called a preheating pulse. Basically, you open the earth tube lever, close the outside air lever, and turn on your main intake and all the exhaust fans at the exact same time, but only for a quick 15 to 30-minute burst, maybe once or twice a day. What this does is push out the stagnant, freezing air in your house and replace it with fresh, 55 to 60-degree earth-warmed air. Then, you just shut all the fans off, trap that earth-warmed air inside, and let your primary heating system gently bring the house up to your final comfort level. It literally saves your main heater so much work.
As we wrap up this explainer today, I really want you to just look out your window and ask yourself a question. Is your backyard just dirt and grass, or is it an untapped battery of free, eternal climate control? Because by simply digging a trench, carefully laying some pipe, and manually managing the airflow, you can harness the constant temperature of the earth to radically improve your home's comfort. It's this beautiful, fascinating blend of ancient architectural principles and accessible modern materials. Seriously, just think about the sheer potential lying right